Day 15, Active Directory. Now we're blue again, right? So we have had a lot of red days. Be it ever so heinous, there's no place like domain control. Okay. Ahead of SOCMUS, the team decided to do a routine check of one of their Active Directory domain controllers. Upon some quick auditing, the team noticed something was off. Could it be the domain controller has been breached? With sweat on their brows, the SOC team smashed the glass and hit the panic alarm. There's only one person who can save us. Learning objectives. Learn about the structures of Active Directory. Learn about common Active Directory attacks. Investigate a breach against Active Directory. Before moving forward, review the questions in the connection card below. Yeah, so we have their VM, the starting one. I think I'm not alone trying to catch up on a little slide. Let's see what it say. Yeah, so the password is AOC investigations exclamation mark, and where will administrator? I'm thinking, can we do this without any characters? Maybe we should, just to be sure. And we need to set the IP, of course. 241.97. And the rest are okay. So, fingers crossed, I didn't close that split screen and had to reopen it. So, I've had lots of problems with Advent of Cyberwire. So now we can use copy paste, all the things. Just focus on actually doing the thing, not having to mess about with other stuff. So, introducing Active Directory. Before diving into Active Directory, let's actually make this a bit nicer to read, right? For everybody. I want people on phones even to be able to read this. Before diving into Active Directory, let us understand how network infrastructures can be mapped out and ensure that access to resources is well managed. This is typically done through directory services, which map and provide access to network resources without another organization. The Lightweight Directory Access Protocol, LDAP, form a core of directory services. It provides a mechanism for accessing and managing directory data to ensure that searching and retrieving information about subjects and objects, such as users, computers, and groups, is quick. Active Directory AD is therefore a directory service at the heart of the most enterprise networks that store its information about objects in a network. The associated objects can include users, individual account representing people or services, groups, collections of users or other objects, often with specific permissions, computers, machines that belong to domain governed by AD policies, printers and other resources, network accessible devices or services. The building blocks of an AD architecture include domains, logical groupings of network resources such as users, computers, and services. They serve as the main boundary for AD administration and can be identified by their domain component and domain controller name. Everything inside the domain is subject to the same security policies and permissions. Organizational units, OUs. OUs contain containers, are containers in a domain that help group object based on department's location or functions for easier management. Administrators can apply group policy settings to specific OUs, allowing more granular control of security settings or access permissions. First, a collection of one or more domains that share standard schema configuration and global catalog. The first is a top-level container in AD. Trust relationships. Domain within a forest or across forests can establish trust relationships that allow users in one domain to access the resources in another, subject to permission. Yeah. Combining all these components allows to establish the distinguished name DN that the object belongs to within the AD. The structure of the name would be as follows: DN, CN, Mayor Malware, OU Management, DC Werewolf, DC TSM. Core Active Directory components. Active Directory contains several key components that allow it to provide a wide range of services. Understanding these components will give one a clear picture of how AD supports administrative and security operations. Domain controllers, DCs. Domain controllers are services that host Active Directory services. They store the AD database and handle authentication and authorization requests, such as logging in users or verifying access to resources. Thank you for the follow.
New follower
multiple DCs
S.
can exist within a domain 3. for redundancy.
Generalism 0S says, I guess I was here with another user then?
You were. It said like new user when you wrote. So you had another account on Twitch.
D.
So thank you for the follow again. They store AD database and handle authentication and authorization requests, such as logging in users or verifying access to resources. Multiple DCs can exist within a domain for redundancy. When changes are made to AD, such as adding users or updating passwords, these changes are replicated across all DCs, ensuring that the directory remains consistent. Global Catalog. The Global Catalog DC is a searchable database within AD that contains a subset of information from all objects in the directory. This allows users and services to locate objects in any domain in the forest, even in those objects that reside in different domains. LDAP, Lightweight Directory Access Protocol. AD uses this protocol to query and modify the directory. The protocol allows fast searching and retrieving of information about objects such as users, computers, or groups. Kerberos Authentication. The default authentication protocol used by AD provides secure authentication by using tickets rather than passwords. Group Policy. One of Active Directory's most powerful features is Group Policy, which allows administrators to enforce policies across the domain. Group policies can be applied to users on computers to enforce password policies, software deployment, firewall settings, and more. Group Policy Objects, GPOs, are the containers that hold these policies. A GPO can be linked to the entire domain, an OO, or a site, giving the flexibility in applying policies. Let us say that McSkitty wants to ensure that all users within Werewolf SOC follow strict password policy, enforcing minimum password length and complexity rules. Here is how it would be done. Using the Run window, open Group Policy Management from your server by typing gpmc.msc. Right-click in your domain and select create a GPO in this domain and link it here. Name the new GPO. Password policy. So let's actually start doing the things we read, right? So I used to work with 80, making like login script and all those stuff. VB script. So let's see. Yeah, right. We could just do this. My fingers. I've been using that. So, GPMC. Micro, come on. Do I have to click it? So, let's say that this isn't quick, right? We can do run as administrator. So, no thing. So, what if we do this instead? There. So, don't trust the search. So, let's see what we have. We have wearable teacher. For the first time, we get to see the domain. So, that's all. There. So, right-click your domain. This is the domain, and select create a GPO in this domain, and link it here, and call it password policy. There. Edit the GPO by navigating to. So let's do. I have to click this. There's nothing else. We see it since I expanded everything. You can see it here as once, and it's located. So let's go back here and read. Edit the GPO by navigating to configure the following setting: minimum password length, enforced password history, maximum password age. Password must meet complexity requirements. So once upon a time, I set these things for you. So. Oh my. Password policy. Here we have domain admins.
Hello. Merry Christmas.
Hi, Merry Christmas and welcome in. So, let's also check all the things, alright? So the rest of them. So here we have who can edit this, right? So let's edit it. And user It doesn't say where they are. I have to go in myself. Oh, it's actually on computer configuration. It does say. Does it? Yeah. Oopsie. Security settings. I'd imagine password settings was on user, but it's on computer? Ah, I don't know. Some kind of Microsoft logic there. So let's go to security. I was already in there. I was already in security settings, sorry. Account policies, of course. Here we have password policy. So, minimum password length. Here. This is supposed to be 12 characters. So, and then enforce password history. And set this to 10. Well, we could just click OK. And then we have maximum password age. So, 90. 42 was the default. That's a nice number, right? It's now the setting for the following items will be changed. Okay. Password must meet complexity requirements. Enable. I'm like, could that even be disabled? But the default was not to set it. Yeah. It was a few years since I looked at this. This is like, really? Click OK, then link this GPO to the domain or specific host you want to target. As we did it this way, it's already linked. This policy will now be applied across the domain, ensuring all users meet these password requirements. Yeah. Common Active Directory attacks. So it's good that I did this because it was long ago, you know? So it's always good to repeat stuff you haven't done in some time. Common Active Directory attacks. Yeah, I should set up a lab ID, really. The mess is only to have, you know, licensing stuff, right? Common Active Directory attacks. Adversaries are always looking for ways to breach and exploit Active Directory environments to destabilize and cause havoc to organizations. Working with the glitch to secure SACMUS requires us to know common attacks and their mitigation measures. Golden Ticket Attack. A Golden Ticket Attack allows attackers to exploit the Kerberos protocol and impersonate any account from the AD by forging a ticket-granting ticket TGT. By compromising the GRB TGT account and using the password hash, the attacker gains complete control over the domain for as long as the forged ticket remains valid. The attack requires 4 critical pieces of information to be successful. Fully qualified domain, FQDN of the domain, SID of the domain, username and an account to impersonate, and a KRB TGT account password hash. Detection for this type of attack involves monitoring for unusual activity involving the KRB TGT. So, this is the new bit here, really, right? These event IDs are nice to know in case you need to protect your environment. And it would be kind of fun to set up this in a lab so that when you test this, you get information about it, right? So detection for this type of attacks. So we have event ID 4768, look for TDT requests for high privilege accounts. So specific for high privilege accounts, or do we have to set stuff? We'll see. Event ID 4672. This logs when special privileges such as SCTCB privilege are assigned to a user. Pass the hash. This type of attack steals the hash for password and can be used to authenticate to services without needing the actual password. This is possible because the NTLM protocol allows authentication based on password hashes. Key ways to mitigate this attack are enforcing strong password policies, conducting regular audits on account privileges, and implementing multi-factor authentication across the domain. Kerberos is an attack targeting Kerberos, in which the attacker requests service tickets for accounts with service principal name SPNs, extracts the tickets and password hashes, and then attempts to crack them offline to retrieve the plaintext password. Mitigation for this attack involves ensuring that the service accounts are secured with strong passwords, and therefore implementing secure policies across the AD would be the defense. Pause the ticket. Pause the ticket attack. Attackers steal Kerberos tickets from a compromised machine, use them to authenticate as the user or service whose ticket was stolen. This attack can be detected through monitoring for suspicious logins using event ID 4768. 4768. TDT requests, especially if a user is logging in from unusual locations or devices. Additionally, event ID 4627 successful login will reveal tickets being used for authentication. Malicious GPOs. Adversaries are known to abuse group policy to create persistence, privileged access accounts, and distribute and execute malware by setting up policies that mimic software deployment across entire domains. With established privileges across the domain, attackers can create GPOs to accomplish goals at scale, including disabling core security software and features such as firewalls, antivirus, security updates, and logging. Additionally, scheduled tasks can be created to execute malicious scripts or exfiltration data from affected devices across the domain. To mitigate against the exploitation of group policy, GPOs need to be regularly audited for unauthorized changes. Strict permissions and procedures for GPO modification should also be enforced. Skeleton key attack. In Skeleton key attack, attackers install malware backdoor to log into any account using a master password. The legitimate password for each account would remain unchanged, but attackers can bypass it by using the skeleton key password. Investigating an Active Directory breach. Group policy. As previously discussed in this task, group policy is a means to distribute configurations and policies to enrolled devices in a domain. For attackers, group policy is a lucrative means of spreading malicious scripts to multiple devices. Reviewing group policy objects, GPOs, is a great investigation step. In this section, we will use PowerShell to audit our GPOs. First, we can use the get GPO command to list all GPOs installed in the domain controller. So let's do this. So just takes me back to when I was making like scripts, running scripts. I also like template package installation and stuff, VBA stuff. Yeah. Long ago. So let's look at the pretty background. So I guess we shouldn't use this, but rather do this. And no. Let's do this and try again because this is. Now I'm curious. Whatever. Yeah, it worked. It worked. So let's get GPO. Oh no, I've got a keyboard problem. Where is it? There. I was tapping. I guess I'll have to type, and there we have that again. So now we can list all the GPOs here. We can see domain name, ID, GPO status, description. Here's the domain, the name of the policy. Here's the one we created now. Then we have default domain controllers policy, malicious GPO, glitch malware persistence. So I would assume that an actual attacker would not call it this, but this, right? Malicious GPO to add backdoor user on all the main German machines. Yeah. So this would allow us to look for out-of-place GPOs. We can export the GPO to an HTML file for further investigation to make it easier to see what configurations the policy enforces. For this example, we will export the set wallpaper GPO, though that's their example because they don't want to reveal the name of the actual one, right? Because it's in the questions. I'm sure we have to type this in here, right? Use the security tab of the event viewer to answer questions 1 and 2. Oh, that's nice of them. Group policy. What's the name of the installed GPO? So here's where we're gonna copy and paste the there. I was sure this name was in here, so there it was. Let's scroll back up. Here. So what we want to do is not to do a GPO report on set wallpaper. We want to do it on this one instead, right? Please note that this is a demonstration GPO. It isn't present in the practical machine. Yeah. So the report type HTML path. So let's just run this command. And now we have we're RDPing. We're not using the split screen thingy. So we can actually just copy stuff, which is nice. So we're going to have to change the name, of course, to this thing. And there. So then we will let's actually use the graphical stuff to go to the path we were in. So, C drive, users, administrator, and we put it on the name set wallpaper. Sure. So here's the report we got, the HTML about this. No settings defined. Okay, so now we can show and hide stuff. I regret clicking that button because now I had to click all the shows. Let's show all. So it doesn't do anything. Yeah, so not this X. Let's do that. Minimize it. I should have changed the name of the file too, right? Here. So it could have had a nicer malware name. There. Then, when opening the HTML file in the browser, we are presented with an overview of things such as desktop wallpaper, because this was their example. From the screenshot above, we can see that the policy sets the desktop wallpaper of devices using the image located in the TSM-JPG of the domain controller. Server share corp. Domains are naturally likely to have many GPOs. We can use the same get GPO command led with a bit of PowerShell foo to list only those GPOs that were recently modified. This is a handy snippet because it might italize policies that were recently modified, perhaps by an attacker. So, modification time. Select object display name. Dot modification time. Where object is what? So it just lists the modification time, it doesn't compare it to anything. So of course we have to run this too. So I'll list the times. So we could sort these two, right? I don't know why they didn't. Event Viewer. Windows comes packaged with Event Viewer. This invaluable repository stores a record of system activity, including security events, service behaviors, and so forth. For example, within the Security tab of the Event Viewer, we can see the history of user logins, attempts, and logoffs. The screenshot below shows a record of user CMNAtic attempting to log into the device. So here we can see the event ID 4648 and very tiny. That's not much bigger. CMNAtic domain variable. All categories of events are given an event ID. The table below provides notable event IDs for today's task. So, a user account is logged on. And I remember there was been a question about that, right? So, 4675 failed to log on. 4672, special privileges has been assigned to a user. 4768, TGT ticket requested for high privileged account. User auditing. User accounts are valuable and often just checking time here. What time is it? There. We have another hour. User auditing. User accounts are valuable and often successful method of attack. You can use event viewer IDs to review user events and PowerShell to audit their status. Attack methods such as password spraying will eventually result in user accounts being locked out, depending on domain controller's lockout policy. To view all locked account, you can use a search AD account commandlet, applying some filters to show information such as the last time the user had successfully logged in. Search AD account locked out. Select object name, some account name locked out, last login date distinguishing. So let's run it at once, right? See if this simple thing works. We had the delayed bar there, so there was nothing. Additionally, a great way to quickly review the user account present on the domain, as well as group membership, is by using the get AD user command list demonstrated below. So let's get this whole line too. Member of, groups, some accounting name, and select object, then get AD user filter star properties member of. So I don't think it's very logical, PowerShell. So these we should put in the notes, but I'm not gonna do it now because I wanna just run through these. I'm just gonna make notes and these for now. But I remember this, right? We have a source of these commands if we need to search for these. So we have a backdoor account here. And the glitch malware. That was kind of like, obviously, it's backdoor is not good enough. We need to mention glitch, otherwise no one will think it was glitch, right? So, yeah. Reviewing PowerShell history and logs, like PowerShell like Bash and Linux, keep a history of commands and put it into a session. Reviewing these can be a fantastic way to see recent actions taken by a user account on the machine. When a Windows server this history file is set console host history. You can use the built-in notepad on Windows or your favorite text editor to review the PowerShell command history. So I guess we should look at it though. So let's actually copy the path and hop over to this one. And let's just run it. And we can see that these commands were us, right? And these are before us. So, nothing interesting there. Just want to see. Additionally, logs are recorded for every PowerShell. Additionally, logs are recorded for every PowerShell process executed on the system. These logs are located within the event viewer under Application and Services logs. Microsoft Windows PowerShell operational or also under Application and Services logs. Windows PowerShell. The logs have a wealth of information useful for incident response. So it's nice to be able to see what people did on the machine, right? So I guess we go event viewer and run it. And we go Application services, Microsoft Windows. And we go PowerShell, operational. PowerShell. Operational. So let's see, what time is it now? It seems that time, these are the most recent ones. Not Microsoft, but Windows PowerShell. So so that was 5 minutes ago. Oh gosh, I don't like Event Viewer. So logs of wealth of information useful for incident response. I guess here we have a warning in there. Oh no. I went into the same place again and had to click everything again. So let's click that warning, right? So, can I double click this? Yeah. But I can't make this bigger without dragging it. So let's just check that they don't want data from this. Look in the partial log file located in... Okay, that's not here. Let's do everything and let's do it again when we get here, right? So I think we were at the end here anyway. Yeah, we're here now. So your task for today is to investigate where will Suckmas Active Directory controller for a suspected breach. Answer the questions below to confirm the details of the breach. Use the security tab in Event Viewer to answer questions 1 and 2. So let's go back here. Let's close that one. And security, I'm assuming they mean this. Tab. This is not a tab. This is a Windows log. That's called security. So, we're supposed to check when the glitch malware last login. So let's just instead of, we're supposed to search for the event ID of logins, I guess. Let's do that then. So let's filter on an ID. Let's see what's on earth that ID was, because I don't remember. So user logged on. 4624. I could type that, right? So I could copy and paste it too. We could also put the name of the user, which is glitch malware. So could this be a keyword? Well, actually, user. That's very nice of it. There is 0 events, though. So let's edit the filter. How do I do that? That's very annoying. So do I have to clear the filter and then filter it again? Oops. What? I didn't copy anything. 4624. If I do this enough, I'll remember all of them, right? Account name, nothing. This would take me forever to check through. So let's, oh my god. It keeps copying stuff. I didn't copy anything. So we have the right ID, confirming that. And I'm a bit tired of this, so let's just do a guess. Just to see. It wasn't right. Log on the event ID 4624, which I might never forget again. And I got to knock on the door. Checked here. Read the partial history. So I did read the history. I just thought that all the partial commands were mine. So let's hop back and just run this again. It's probably in the run history. So let's, yeah, there. So yeah, so it's the same almost as that we run. So let's copy that. I didn't see that I didn't run it. Look in the partial log file located in the application server. Partial what? Let's do this one first, right? Because I want change. And then I'm thinking my filtering might be off there. So let's go Windows partial. And here we're supposed to find glitch. What was glitch malware? Set password. So in here. Oh my. So let's actually search for this glitch malware, because if it says something about a username password combination, no, it should really be mentioned. So if we filter and we filter on. I can't do keywords, so I guess I can do user. No, because this is just odd. I should just like find instead, not this. So let's clear filter and actually use find instead. And we want to find this. And this time we were successful. We were not in the other log. So I don't want to cancel, but I want to see this. So I have to cancel it then. Okay, so glitch malware add. So this is where glitch malware is added. So wait. So here is add command, but they're not setting the password. So next command is what? So this is so horrible way of viewing stuff. I should have not kept this resolution. I should have connected with another one. Let's do scale desktop 100 instead, because I can't see enough, right? So we'll have tiny text, but I will see more. So this wasn't useful. I'm trying to be stream friendly here, and it makes me not being able to see stuff. So if we do find, we do glitch malware, and now we can see stuff. We can see the ad. Is the user added several times? User ID, host name. Pipeline execution details. Now I'm curious if we have a dollar password. But what would dollar password have been then? So now we actually know there's a dollar password, right? So if we now do a find for password instead. So there's no up, and I don't like the search. Simply, it's horrible, the event here. It's just horrible. Yeah, I should find better ways to view events. Yeah, so I will have to stop soon. So let's see if we can find the first one again. So security, find, And can we Control C this? Of course we can't. So I'm just gonna copy glitch malware from the screen, paste, find. So now we have a logon. The problem is that I tested all dates, and this shouldn't work because it's day. Oh, I didn't read this. So this is the normal format, but this is not the format the log is in. So I have to turn the dates around. Okay, I'm sorry for guessing. I'm just tired of this. So what we saw here was 7. Yeah, 07. So I assumed 2-digit day number and that this couldn't be correct because it was 7. And I had already tried 11-7. So they've added so many features that it added a 0 here when we corrected the answer. So 7, it was actually correct. You didn't have to type 07. But they could also have added using the same format that the logs do as an okay answer. If that had been the case. So we read that. So for question 1 and 2, security tab and event viewer, those two. And then read the partial history, we did that. Look in the partial log file. Hi.
Hausugan says, hoist. Translated from
Hey, Space. Welcome in. So, let's see here. Partial logs.
That's not Danish greater than.
I'm Swedish. So, look in the partial log file located in application and service logs. So we were in this log just now.
Yes, exactly. Translated from Swedish.
Yeah. So, what was glitch malware set password?
Translated from Swedish.
Oh, right. Yeah, so it's sometimes it guesses the wrong language. Right. And also, I don't know what it was translating it to there, really. It wasn't the correct word. Right. So let's actually look at the hint here. Use a find option, search for password. Yeah, I did that. Let's do it again. Let's go to the top. We haven't moved now because we just hopped into this again. And let's do password here again. Because we know that its password is set to $password. So let's continue searching for password. So can't scroll. So let's actually see what I can't see. Let's actually do this. Since we're searching, it doesn't matter anyway. Now we'll see all the things, right? So if we do find password next, now we should be able to see like all the things here. So we want to see where password is set. And it must have been set then with PowerShell. And I don't dare to hop quickly because I might miss it. And here says account password for this account. Let's read the whole thing. PowerShell command password. Oh, look, I wasn't reading the whole thing. It's actually in the command. Password equals convert to secure string, super secret password.
Evan Stevens says,
I wasn't reading it.
hi.
Hi, welcome in. So, I wasn't reading it. Let's get that last character. And this is when I went more. Let's see here. There. Let's copy that over here. So, there. And active directory hardening room I have not done. So let's just hop it over to my try hack me somewhere at the middle or upper middle kind of thing. There.